For more videos like this for Discrete 2, you can take a look at Story Studies, link is in the description box below. We're told Joe Long worked on 9 music projects last year. He wrote and produced 3 projects, he wrote a total of 5 projects, he produced a total of 7 projects. And then we have some questions to answer, and they're telling us to use Venn diagrams to answer these questions. So as soon as you hear the word Venn diagram, the first thing you need to do is draw the universal set U that contains all of the elements of consideration. And what are the elements we're considering? Well, we're considering Joe's 9 music projects. So imagine that in this box, in this set, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 projects under consideration. Now the idea is that out of these 9 projects, there's a set of them that Joe wrote, there's a set of them that Joe produced, and then there's a set of them that Joe both wrote and produced. So we have to define these sets. So first, we have that the universal set is a set of all Joe's projects. We know that the number of elements, in this case projects, under consideration, so in the set U, are 9. So out of these 9 projects in this box here, we have a set of them that Joe wrote, so we're going to have a set called W, which will be the set of projects Joe wrote, so W for wrote. And then we also have a set of those projects that Joe produced. So we're going to have a set P, which is a set of projects Joe produced, so P for produce. Now, why do I draw them overlapping and not separately, like W here and P over here? Because if you look at the problem, there are projects that have been both written and have been produced. So there should be some overlap between these two sets. Now, in order to fill in our diagram with what we call cardinal numbers, you want to translate the information that they give you into set theory notation. So we already did this part. Let's start from the bottom here. So they're saying he produced a total of 7 projects. What this is saying is that there are 7 projects that go in the set of projects Joe produced. So the number of elements that go in set P are 7. Or you can write it as the cardinality of set P is 7. Cardinality is just the size of a set, how many elements there are in a set. Hence why these numbers right here that we're going to be putting into our Venn diagram are called cardinal numbers. Next, we have he wrote a total of 5 projects. So the number of projects that he wrote, so the projects that belong in set W, the number of elements in set W, is equal to 5. And finally, he wrote and produced 3 projects. That means that the number of projects that he both wrote and produced, so the number of projects that go in this section right here that belong to both sets, is equal to 3. So the way we write that is that the number of projects in set W and set P is equal to 3. And what is the symbol for and in set theory? Well, we have 2 main symbols, this one, and we pick the one that looks more like an A, so this one. And we replace it with that symbol. So now I'm going to move everything over. Now the strategy in which we fill out the Venn diagram is always fill out the smallest parts first. So I'm going to fill in what this part is, and then I move on to the bigger parts. So I ask myself, how many elements belong in this region or this set? Well, any elements or projects that are in this region are projects that have been both written and have been produced by Joe. So you go to the information that they give you and you ask yourself, do they give me that information? Do they give me the number of projects that Joe both wrote and produced? Yes, right here, that's 3. So we say that this region's cardinal number is 3. Because again, cardinal number. Cardinal means cardinal for cardinality. Cardinality means how many elements in a set, how many elements in this region, hence it's 3. And we get that from over here. And because in Humanities class you always have to write down your formulas, this would be the formula it's given to you. Now that we're done with the smaller parts, we can move on to finding the cardinal numbers, or how many elements or projects there are in these larger parts. So let's say I want to find out what number goes in this region or in this set. Well, this region is part of set W. So let's go into the information they give us and see if they give us anything related to W. Well, they tell us that the number of projects in W is 5. So that means the number of projects, the number of elements in this entire set over here is 5. And that includes these 3 because this 3 here is part of the set W. So if I want to find what this region is, how about I take the total number of elements in this set, subtract what I know is already in the set to find out what's missing. So we're going to take the number of elements in W, which we know is 5, we're going to subtract this part, which we know is 3, but how do we represent that using a formula? Because this is how we show our work in Hamidi's class. Well, we know that 3 is represented by this formula. It is the number of projects that have been both written and produced. This region right here. So this is the number of projects that have been both written and produced. So the cardinal number for this region is 2. And you can always check your work. You know that the number of projects in set W is supposed to be 5. So all of the cardinal numbers inside W should add up to 5. And do they? Yes. 2 plus 3 is 5. So in total, we have 5 projects in set W. And this is what you would have to write on Hamidi's tests or quizzes in order to get full points to show your work. Next, let's find the cardinal number for this region. So it's the same strategy. You're trying to find something in set P. So go here. Do they tell you anything about set P? Well, they tell you that the number of elements or the number of projects in set P, so this P circle, is supposed to be 7. So in total, there's supposed to be 7 projects in here, which include these 3 projects. So if I know that the total number of projects in set P is 7, but I want this part, and I have this part, then I just have to subtract this part to get the missing part. So I'm going to take the total number of projects in this circle, which is 7, and I'm going to subtract this part over here, which is 3. But how do I represent that using a formula? Well, this part is known as the number of projects that have been both written and produced. And so we get that 7 minus 3 is 4. So we have that the cardinal number for this region is 4. And you can always check your work because you know that the number of elements in set P is 7. So all of your cardinal numbers in set P should add up to 7. And do they? Yes. 4 plus 3 is 7. And we're not done just yet. There's one more number you always have to solve for, and that's how many elements in the universal set are not part of any of these sets. Notice that the number of elements in the universal set is 9. So in total, we should have 9 elements in this set, 9 projects. So all of the cardinal numbers that you have inside this box should add up to 9. And do they? Well, I see 2 plus 3, that's 5, plus 4, that's 9. So great. We accounted for every single project. So the number of projects or elements that are not part of any of these sets, so the number of elements outside of this entire region is 0. But that's only in this problem. In other problems, there might be elements that are under consideration but don't belong to any of set. But in this problem, there's 0. How do we represent that using a formula? Well, at the end of the day, we want to figure out how many elements are outside any of these sets here, this entire region. So then the question is, okay, I want everything but this region. And that sounds very similar to the complement. I want the complement, the opposite of this region. So I have to first find a way to define this region, and then I can just take the complement of it, and then find the number of elements in that region, which would be everything outside of it, which would give me 0. So again, how do we define this region? Well, this region really is set W and set P together. It's this entire thing. And when we want to join all of the elements into sets, what do? We do union. So we're looking at the union of sets W and P. So this region right here, and we want everything outside of that region. So we're going to take the complement of that. So now the region we're looking at is this region right here. And we want the number of elements in this region. Now again, anytime you're doing complement, Hamidi's class, you always have to write the formula for the complement. And that would be the number of elements in the universal set minus the number of elements in whatever you want to take the complement of, which is the union of sets W and P. So we know the number of elements in U is 9. And then we're looking at W union P. Union means we're joining all the elements of this set and putting them in one set. And then we're looking at the number of elements in this region over here. So if you look at the Venn diagram, union just means putting them all together. So you take set W, and you take set P, and then you're looking at the number of elements in this region. That's 2 plus 3 plus 4. So in total, that is 9. So you could say this is 2 plus 3 plus 4. And that gives us 0. And that is how we get that answer. But let's say that Jill worked on 10 music projects last year, and then all of this remains true. Now the number of elements in a universal set is 10. So this here is 10. And then we subtract all of the elements in this region over here, which contains 9 elements. So you would have 10 minus 9, and then we would have 1. So that means that there's one project right over here that is still inside the set of projects that Joe worked on, but doesn't belong to any of these sets. He didn't write nor produce the project. Maybe he was just a supervisor or something. So that's something that you have to watch out for, how to calculate this number. And by the way, you could have just done this. You didn't really need to interpret it this way. That's how I interpret it. And then you have to write down the formula for complement. But if you just want to go straight to this, I think that's easier. That works fine. Now that we're done with the Venn diagram, we can use them to work on the problems, on the questions that they ask us. That's the whole point of this section. Venn diagram, and then use it to answer questions. So for part A, we're asked how many projects did he write but not produce. So we're looking for the projects that are in set W but not in set P. So we want not P. So for part A, in terms of a formula, we're looking for the number of elements in set W and the number of elements that are not in set P. So projects that have been written and or but have not been produced. So we basically want to identify what this set is visually. What is the region that this set describes? Well, we're looking at set W, which is this entire set over here. That's anything but set P. So that's literally anything outside of the P circle. Anything outside of this circle, including all of this space right over here. And we want the overlap, the intersection between these two regions, between these two colors. So where do these two colors overlap? Where do I see both red and blue? Well, I see red and blue over here in this region. I don't see any red over here where the 3 is. I don't see any blue outside over here. So this set represents this region over here. And the number of elements in this region, in this set, is equal to 2. So the answer here is actually 2. But because we have to show our work, we have to show formulas. So the question is, how can we write this in a formula? Well, one way to think about it, if at the end of the day, this is the region that you ended up with, then you can actually start with the entire W circle, the W set, so the number of elements in set W, and then just subtract this part. Because if you just want this, and I'm starting off with the entire thing, then just get rid of this 3 to end up with what I want. So I want to subtract 3, but how can I represent that with a formula? Well, we know that this region in the middle is represented by the number of elements in set W and set P. So set W minus anything that is in set W, but also in set P. So it's going to get rid of this 3, and we're left with this region right here. So number of elements in W, that is 5 minus number of elements in W and P. So that intersection right there is 3, and then we're left with 2. So this is how we break up that formula there. And sometimes they may ask you to describe the region in part A, in part B using set operations. And this is the region. So you could say the region described in part A is the intersection of set W and everything not in P. And then part B, we're looking at how many projects did he produce but did not write. So we're looking at the number of projects that he did produce and or but, so but and are the same thing, did not write. So we want all the projects that are not in the writing set or in the set of projects that he wrote. So it's literally the same thing. First, let's solve it visually. We're looking at set P, so this entire set over here, and then we're looking at everything not in W. So everything outside of the W circle is what we want. So that includes all of this here. And then we're looking for the overlap, the intersection between those two colors. So the only place I see purple and red intersecting is this region. I don't see any purple here in the 3 region. I don't see anything in here. I don't see any red outside here. So I'm simply left with 4. So my answer is 4, but of course we have to write down the formulas. So one way to think about it again is start with your entire set, so the number of elements in set P, and then we only want this part, so I just have to subtract this 3. And in formula terms, this 3 is represented by this formula, so that's going to be the number of elements in the intersection of set W and P. We know that the number of elements in P is given to us, that is 7, minus the number of elements in W and P that is given to us, that is 3. 7 minus 3 is 4. And that is our answer. And again, they might ask you to define the region being talked about in part B, not just the number of elements in that region. So you could just write a little sentence like, the region described in part B is this region right here, the intersection between P and everything not in W.